Welcome! This is a third section of our algorithms course, and in this section we'll be looking at the topic of sorting and recursion. So we'll be looking at the bubble sort, that this is the simplest algorithm for sorting integers. We also will be looking then at the more complex algorithm, that is a heap sort, and gives us a lot better performance for sorting values. Then we'll be looking at a very powerful and important technique when creating algorithms. So we'll be looking at the recursion. At the end, we'll try to optimize it using tile recursion. That is a lot better approach for solving those problems. And this is a first video. In this video, we'll be looking at the bubble sort. This is a simple method of sorting. It is easy to understand. So we will be starting from that simple method. We'll answer a question on what is a bubble sort. We will also try to analyze that algorithm and find out what is a big O notation of bubble sort. At the end, we'll be implementing and testing bubble sort algorithm in Java programming language. So let's answer a question of what is a bubble sort. So that sorting works like this. It repeatedly steps through the list to be sorted, compares each pair of adjacent items and swap them if they are in the wrong order. The pass through the list is repeated until no swaps are needed, which indicates that the list is sorted. So let's see an example of how bubble sort works. So let's say that we have an input of such values. So we have array of 5 values, 4, 2, 5, 1 and 7. In the first iteration of this algorithm, we will take 4 and 2, we will compare those and swap them, because 2 is of course smaller than 4. Then next iteration will compare another pair, so it will compare 5 and 4, and it is in proper order, so we will be not swapping it. Then next iteration, so 5, 1. 5, 1 of course wrong order, so swap. Then 5, 7 is proper order, we don't need to swap. Then another iteration, so we are comparing 2 with 4, 4 with 1 and we are swapping it, 4, 5 and 7 stays as it is. We know that it is already sorted. Then next iteration, so 2, 1 is wrong order, so we are swapping. 2, 4 is okay. 5, 7 is already sorted, we don't need to swap it. And last iteration we are comparing 1 with 2. It is in proper order and 4, 5, 7 is already sorted, so we don't need to swap it. So we can see that to sort the 5 elements array we need 4 iterations in this example, but each iteration also needs another iterations. So it will be a time complexity of O(n square). So this is not a good complexity, but for the simplest case and smaller inputs could be okay. So let's implement our bubble sort algorithm. We will start from looking at the test, of course. So this is our test for sorting integers. We will create a new instance of bubble sort algorithm and we will have an interface sort. Let's look at this interface. This interface will have only one method, sort, that takes an array of integers and sorts that array in place. So we don't need another data structure, doesn't need to return nothing, so it returns void. Then we are creating an array of inputs and this will be array of integers and we are adding integers that are out of order. So it will be 4, 5, 1, 2, 10, 20 and 1 again. Then after invoking the sort method on the bubble sort implementation, we need to assert that input contains exactly those numbers 1, 1, 2, 4, 5, 10 and 20 in exactly this order. So let's look at the implementation of bubble sort algorithm. The sort method is fairly simple. So we take the integer array as an argument. We need to know the n, so this is a length of our array. And we also need to have temp element to which we will be assigning some values, and we are just initializing that value to 0. Then we will have first for loop that iterates over every element in that array. And then another for loop that is inside of it, and it will iterate over every element, but in each iteration we don't need to iterate to the end element, but we are iterating to n minus I. And this is exactly the same that we are analyzing previously. And this is our logic of comparing elements. So if the element, previous element and next element is higher, so it is in wrong order, we need to swap them. And swapping is very simple. So we are just taking that element that needs to be swapped. We are assigning that element to the temp integer. We are changing the first value, and temp is assigned to the previous value. So we just swap those integers, and we are repeating it for every element. So those are two for loops. And because of that we have outer loop and inner loop, it means that we have O(n) square complexity. Always when we have two loops, it means that it's O(n) square. So let's start our test. And we can see that our test passed. So our bubble sort algorithm proven well. So it sorts the integers and we are able to use it, but only for small input because this is a very simple algorithm. One of the pros of that algorithm is that it doesn't need to have any additional data structure. So we only need to use array and it uses it in place. So we are swapping elements in place. Doesn't need to create some additional data structure and doesn't need to occupy some additional memory. And this is one of the biggest pros of this algorithm.